Hello friends, in this video you will continue your exploration of fundamental building blocks of Python. Now moving on specifically to work with dictionaries. This video assumes that you have an interactive Python development environment such as Jupyter installed and are familiar with the defining variables and invoking simple built-in functions. If you are unaware, you can visit my previous videos to know more about these concepts. You will also need to be familiar with working with lists and with operations such as slicing. So in my previous videos, you can visit and see all these concepts and learn about it. As far as this video is concerned, you will work with a dictionary, another extremely important data type in Python. You will see how dictionary are associative containers used to store key value pairs and the associated value in optimize by Python to be extremely efficient. You will see how all keys in a dictionary need to be unique, while values can contain duplicates. So let's talk about a dictionary first. It is an important complex data type which you will often find use in Python. Let's first initiate an empty dictionary. Observe that a dictionary is basically just curly brackets. So anytime you specify a dictionary, you have to use the curly braces in Python. A dictionary in Python can be best defined as a mapping of key value pairs. And a dictionary allows you to look up a particular value once you specify the key. Let's see how this is set up. Here we are going to initiate a dictionary of bike_owner. Notice that all of the key value pair are specified within curly brackets. This is important. That is what indicates to Python that it is a dictionary. And all of the keys in this dictionary are the names of owners of motorcycles, like James, Jacob, William, Aiden, and all of the values in the dictionary are name of bikes, like the Ducati Monster 1200, the Harley Davidson, the BMW, and so on. A record in a dictionary is a key value mapping. An individual record are separated from one another using commas. So one record is the key James and the value Ducati Monster 1200 that James owns. And notice key and values are separated using the colon. And a record that is a key value mapping, that is the record for the key James, is separated from the record for the key Jacob using a comma. This is a dictionary, and let's take a look at the resulting dictionary that was created. Now the cool thing about a dictionary is that you can specify a key within square brackets and get the corresponding values. So if you specify bike_owners square bracket James, you get the Ducati Monster 1200, which is the bike that James owns. If you want to find out what bikes Aiden owns, you will specify Aiden within square brackets and the dictionary will return the Harley Davidson. It is important to remember that dictionary allows you to look up a particular value using the corresponding keys. If you try to specify a value within your dictionary that is not valid, there is a key error that Python throws indicating that the BMW S1000R is not a valid key within the dictionary. Even though the BMW is a part of this dictionary, it is a value. It is not recognized as a key, and that is why you see this error. The most common data type used as a key in a dictionary are strings. However, you can specify integer values as your keys as well. Here is a dictionary where all of the keys are integer values. 1, 2, and 3 are the dictionary's keys. It is so happen that the values corresponding to the keys of this dictionary also happen to be integers. When the keys of a dictionary are integers, you need to specify these integers within square brackets to look up corresponding values. So the values corresponding to the integer 2 is 55. Now it's important to remember that the keys in a dictionary have to be unique. That's the only way you can use a key to look up a particular value. Observe this dictionary that we have created here. You can see that the keys are 1, 2, 3 and 3. So the key 3 appears twice. The key 3 is not unique. Now if you initiate this in dictionary, you can see in the resulting dictionary the key 3 appears exactly once and it is associated with the value 75. This means that the Python has simply taken the last value assigned to that key. The first value that we assigned to the key 3 was 85. It has been overwritten by the last value assigned to that key, which is the number 75. Let's now set up another dictionary containing some student underscore details. The keys of this dictionary are strings and the values are numbers representing the years in which these students were born. Just as a list and tuples, there are functions that you can invoke on dictionaries as well. The .keys function into a dictionary will give you a list of all of the keys present in that dictionary. These are the names of our student Henry, Samuel, and Ingrid. You can use the Python in keyword to check whether a particular key is present in the dictionary. Here we want to know whether the name Samuel is present in the student underscore dictionary. We check within keys and Python says true because Samuel is indeed a key. This way we can check for other student name as well. Is Andrews within the student underscore details key? No, that's why Python returns false here. Let's check for Henry and Python correctly returns true. There is another helpful function that Python dictionaries have, and that is the value function. And this function allows you to access all of the values present within the dictionary. Here are all of the years in which the students were born. It is not necessary in Python that all of the keys and values for a dictionary be of the same type. We can have mixed dictionary. Notice here that the keys are Boolean, values and strings. And the values are a string, a list and a Boolean value. Now this is a dictionary that may be hard to use, but it is perfectly valid. And Python has accepted it and created this dictionary for you. Let's look up the values associated with the key area. That is the list 1, 2, 3. Let's perform another lookup here. We will look up the values associated with the Boolean false, which is the name Daniel. All of these work perfectly well. Dictionaries in Python are often used to hold different kinds of information about entity. In this particular dictionary that we have created, the entity is a bike. And the details of the bike are the name of bike owner, the model, the price, and the displacement of the engine. The keys indicate the properties of the entry, and the values are the values of those properties. Here are the bike underscore details. Once we have created a dictionary, it is possible to set a new key value mapping in the dictionary. You simply specify the square brackets and the name of the key and assign a value. If you take a look at the bike underscore details dictionary now, you will find that its key value mapping has been updated to include the key value num underscore cylinder and 2. In addition to adding new key value pairs to a dictionary, you can also update the value associated with a particular key. Here, I want to update the price of this bike to $29,140. And if you take a look at the bike price, you will find that the corresponding price has been updated. In addition to using square brackets, you can also use .get function on a dictionary to look up the value associated with the key. Call .get, pass in a key, and you will get the value in return. Within the bike underscore detail dictionary, the price of our bike has been updated to reflect the new values that we assigned. You can take a look at bike underscore details and find the update in here as well. Dictionaries in Python, unlike tuples, are mutable. If you find that a particular key value pair no longer makes sense within a dictionary, you can call the del command or the del keyword and pass in the key that you want to delete. Here I want to get rid of engine underscore displacement key, and if you take a look at the bike underscore details, you will find that the engine underscore displacement key corresponding values has disappeared from this dictionary. Now let's discuss about nesting complex data type within dictionaries. Let's continue working with Python dictionaries and see how dictionaries can hold within it other complex data types such as tuple, list, or strings. I will first create a completely empty dictionary called fruit underscore qty, that is short form of quantity. Remember, the empty dictionary is simply specified by an empty pair of curly braces. Once this empty dictionary has been created, you can add key value pairs to this dictionary using the assignment operators. Here all of the keys are name of fruits such as banana, apple, and apricot, and we have used the assignment statement to assign the quantity of fruits available. If you now take a look at fruit quantity dictionary, it is no longer empty. The key banana is associated with the value 50, apple with 78, and apricot with 40. You can use the square bracket notation to update and set up new key value pair. I have added orange and avocado to fruit underscore quantity dictionary, and these fruits are now also available within fruit quantity. Orange and avocado are new keys which are present along with their corresponding values. As we have seen earlier, you can now use the square bracket notation, and within the square bracket specify the exact form of the keys whose value you want to look up with within the dictionary. What is the quantity associated with the key apricot? Well, it is 40, and that's what Python gives us. If you are using string keys within your dictionary, remember that they are case sensitive, so you have to specify the key in its exact form. If you try to look up a value for a key that does not exist within a dictionary, Python will give you a key error. You can now update this dictionary to include the key watermelon, and you have 10 watermelons within your fruit underscore quantity. You can see that the fruit underscore quantity dictionary now includes watermelon. If you now try to look up the key watermelon, you will get its corresponding value 10. In this particular dictionary that we have worked with, the keys were strings and the values were integers. It is also possible to have values with complex data types. Here I am going to have a dictionary called fruit underscore quantity underscore consumed, and the keys are a string which are fruits, banana, apple, apricot, orange, and avocado, and the values are lists. For each of these fruits we have associated a list of values, and this is perfectly legit and allowed in Python. If you take a look at the fruit underscore quantity underscore consumed dictionary, you will see that all of the keys are values which are the quantities of fruit that were sold on different days of the week sale. If you want to find the values associated with a particular key, you will use the square brackets and specify the key that you want to look up. Python returns a list of oranges consumed on, say, different weeks of days. We don't know what the week's days are. That is just a list. Remember that list can also be accessed using index positions specified within square brackets. So you can access fruits orange, and within that list you want to access the quantity consumed at index position 3, and Python will give you 65, the value at index position 3 in the list associated with the orange key. I will now access the list associated with the key avocado, and this will give me the list 30, 50, 40, and 45. Now if you want to update a particular element in this list, you can do so using two square brackets. The first set of square brackets has the key avocado that will help me look up the list associated with the avocado key, and the second set of square brackets specifies the index position of the element that I want to update. I'm going to update this value to be 50. And now if you look up the list associated with avocado, you will find that the last element at index position 3 in this resulting list is 50. This is the updated value that we have specified. The values of dictionaries can be dictionaries as well. So dictionaries can have any kind of complex data types in its values. Here is an updated version of fruit underscore quantity consumed dictionary. Here the keys are names of fruit and the values are dictionaries, where the keys within the nested dictionaries are the days on which these fruits were consumed. Let's take a look at the fruit banana. On Friday there were 70 bananas consumed, on Saturday 80, and on Sunday 95. The fruit underscore quantity consumed here is an example of a dictionary nested within an outer dictionary. If you look up the fruit underscore quantity consumed dictionary with one set of square brackets, this will give you the dictionary of how many apples were consumed on different days of week. You can use two square brackets to check up how many apricot consumed only on Sunday and you get the result 95. The first pair of square brackets look up the outer dictionary, that is, we use apricot to get the dictionary associated with apricot, and then we use the second pair of square brackets to get the value associated with the Sunday in the nested dictionary. Let's take another example of nested loop. Here we have the apricot fruit present within our dictionary, but we have no fruit underscore quantity underscore consumed for Monday, and Python rightfully throws an error. The key Monday was not found within the inner nested dictionary. Now let's continue our study of Python dictionaries by seeing what functions and method can be invoked on these dictionaries. I'm going to initiate the dictionary that we worked with before, the bike underscore details dictionary, containing the owner, model, price, and engine displacement for a bike. Dictionaries can be passed as input argument to the built-in len function, and this will give you the number of records or key values in a dictionary. The bike underscore detail dictionary has 4 key value pairs, which is why the length is 4. We have already seen the key functions that you can invoke on a dictionary to access all of the keys present. You can see the length of keys in this dictionary is 4, and the length of the values in the bike underscore details dictionary is also 4. The built-in function sorted sorts the value present in a collection such as a list or a tuple and return sorted values. When you pass in a dictionary, it will return a sorted list of the keys in the dictionary. The sorted function has accessed all of the keys in bike underscore detail and return the key in the sorted order. The built-in function sorted takes in additional input as well if you want to sort your collection in the reverse order. Pass in reverse equals to true, and the keys in your bike underscore details dictionary will be sorted in the reverse order. See you in the next video. Till then, happy learning. Goodbye.